Hey guys, this is Coach Lowe, and we're going to finish up our review for Chapter 8 test. So this is part 2, and we're starting with number 12. So a boat is 2,000 meters from a cliff. If the angle of depression from the top of the cliff, so this would be the angle of depression, is 10 degrees, how tall is the cliff? So angle of depression from the cliff to the boat is 10 degrees. So remember, parallel lines cut by a transversal, if this is 10 degrees, then so is this. So now we have an angle inside our right triangle, and they want to know how tall the cliff is, so we're looking for this side. So here's our angle, right triangle, so we can use SOHCAHTOA, and let's see which one we need to use. X is opposite 10 degrees. 2000 is adjacent. Hypotenuse we don't need. So opposite adjacent is tangent. So tangent of 10 degrees equals x over 2,000, or 2,000 tangent 10 is equal to x. So x is 352.7 meters. All right, number 13. A plane is flying at an altitude of 10,000 feet. It begins descending when the end of the runway is 6,000 feet from the point on the ground directly below the plane. So here's the plane. It's at 10,000 feet. It begins descending toward a runway when it's 60,000 feet away. Find the measure of the descent or the angle of depression to the nearest degree. So we are looking for this angle of descent, which is also this angle for parallel lines cut by a transversal. So we're looking for this angle. So let's see what we're given. We have opposite and we have adjacent. So that's tangent of theta equals 10,000 over 60,000. So tangent inverse of 1 over 6 after we cross out all those zeros. So tangent inverse of 1/6 is 9 degrees. So that angle of descent here is 9 degrees. All right, number 14. So as we check this problem out, we look to see if we have any right angles. We're trying to find this side length. So do we have any right angles? No. So now we need to decide, is it law of sines or law of cosines? So remember, look for law of cosines first. If we have 3 sides that are given, law of cosines, or if we have 2 sides in the angle between, law of cosines. Other than that, law of sines. So do we have 3 sides that we know the values for? No. Do we have 2 sides that we have given values for in the angle between? No, we just have one side given. So this forces us into law of sines. I see that I'm missing an angle here. So we can add 68 and 42 together, which would be 110 degrees. Subtract that from 180, which would be 70 degrees. And that gives us this angle. Now we can use law of sines to find our missing value. So sine 42 over 23 equals sine 70 over x. So cross multiplying, or if you remember, we can do our little quick shortcut. So when I cross multiply here, 23 sine 70, and divide that by sine 42, swapping places with these two, that's equal to x. And so now we are ready to just pop that bad boy into our calculator, and we should come up with 32.3 for x. All right, let's look at the next one. Is this law of sines or law of cosines? I'm given 2 sides and an angle, but do I have an angle with 2 sides around it given? So 2 sides in the angle between, I do not. So again, this is law of sines. So I'm trying to find this angle, and this side is opposite that angle. I'm given this angle, and there's my opposite side. So sine x over 6 equals sine 38 over 17. So sine x is equal to 6 sine 38 over 17. Pop that on the calculator. Remember, we're going to use inverse sine on this. So I have sine inverse of 6 sine 38 divided by 17. And so remember, when you're doing this, we have to use sine inverse. So let's round to the nearest degree. So it's 12.55, blah, blah, blah. Rounding to the nearest degree gives us 13 degrees. All right. Number 16, a tree grew at a 3-degree slant from vertical. So here's vertical. It's at a 3-degree slant, so that makes it 93 degrees. At a point 60 feet from the tree, an angle of elevation to the top of the tree is 14 degrees. Find the height of the tree to the nearest foot. All right, so again, we're given 2 angles and a side. This is law of sines. Law of cosines would be 3 sides or 2 sides and the angle between. All right, so we need to find this angle. So we can add these two together and then subtract from 180. So let's do that. 14 and 93. And then subtract that from 180. So this angle is 73 degrees. So now law of sines. So sine 73 over 60 equals sine 14 over x. And we can solve this pretty quickly. 60 sine 14 divided by sine 73 is x. So switch places with these guys and multiply across. And I have 60 sine 14 over sine 73. Now, we're talking about this shortcut. We've worked on this for a while, but we know that we can get rid of the 60 by multiplying both sides by 60, multiply both sides by x. So I'd have x sine 73 equals 60 sine 14, and then divide both sides by sine 73. We've just done that so much that now we see multiply across, divide by that, we're good to go. All right. So when we put this on our calculator, 60 sine 14 divided by sine 73, we should get 15.2 feet rounding to the nearest foot. All right, check out this next one. Find x to the nearest degree. All right, so now I see we're given 3 sides. Automatically law of cosines. We're trying to find the angle. So remember, we solved law of cosines so that we could plug these guys in. All right, so cosine x is equal to 16 squared plus 9 squared minus 8 squared over 2 times 16 times 9. So remember, the angle that we're looking for is this squared plus this squared minus the angle or the side that's opposite the angle. And that's the only time you'll see it. So this goes back to x squared equals, well, let me do a. A squared equals b squared plus c squared minus 2bc cosine a. Solving this for cosine a gives us a chance to just pop things in that formula. So that makes it kind of nice. All right, so cosine inverse of this mess. And remember, when you put this on your calculator, here's what the keystrokes look like. 16 squared plus 9 squared minus 8 squared, close the parenthesis, divided by, open the parenthesis, 2 times 16 times 9, close that parenthesis, close that one. If we don't open and close parentheses in here, your calculator does order of operations and it will divide by 2 before it multiplies all these together. So instead of dividing by this whole thing, it'll just divide by 2. It messes everything up. You get a domain error. It's crazy and nuts and wrong, more importantly. All right, so when we finish this, we're supposed to round to the nearest degree. And so that gives us 19 degrees after popping that in on our calculator. All right, couple more here and we'll be finished. So for 18, I'm going to go ahead and draw the triangle down here. So angle x is 156 degrees. We'll put y and z here. Y is 18. Z is 21. I have sides and the angle between. That's law of cosines. And I'm trying to find x. So x squared equals 21 squared plus 18 squared minus 2 times 21 times 18 cosine of 156. So again, beautiful formula here. When I'm using law of cosines, I'm targeting this angle is going right here, and the sides around it are what I use to fill in these guys right here. So it's so lovely. All right, once we put this in our calculator and we take the square root of it, we should get x is equal to about 38.2 once we round. All right, so beautiful thing. Don't forget to take the square root, because once you just put this all in your calculator, that's equal to x squared. So we need to make sure we take the square root. All right, number 19, we have vectors going on here. So vector PQ, I'm going to go ahead and just sketch this real quick. We want magnitude and direction of this guy. So -2, 1, 2, 3, 4, and -5, -6. All right, so my vector is coming this direction here. Stopped on me, didn't it? There we go. And this is P and this is Q. So the length of this vector, so when I find the length, remember we want distance formula, or the magnitude of this vector looks like this. So I want the square root of -5 minus a -2, so it changes that to plus squared, plus -6 minus 4 squared. So I have the square root of, remember this is x2 minus x1, so there's x2 and there's x1, which is -3 squared, plus y2 minus y1. So I have the square root of 9 plus 100, or the magnitude, we'll put, that's not absolute value, but magnitude of PQ is the square root of 109. All right, tangent gives me the direction, tangent of this angle. Remember, direction looks like this. I want this angle. I want that angle right there, but I'm going to get this angle when I use my calculator, but I want this one. All right, so let's talk about this guy right here. Actually, let me back up just a little bit. Remember, we're here and we're looking for this angle. All right. We're going to get this angle right here, but we'll add 180 to it and get all the way around. All right, so tangent, change in y over change in x. So theta equals 73 degrees. And I do believe it's about 73.3 degrees. But that's this right here that's giving us this angle right here, and we need to go all the way around because this is pointing in the negative direction, so we want to go all the way around. So it's 180 plus 73. So drawing that picture will help you a ton. So 253 degrees. All right, last one. It says copy the vectors d minus f, and so d looks like this. And f looks like this. All right, so minus f, or let's write it this way, d minus f is the same as d plus the opposite of f. So I'm going to take f and I'm just going to take it in the opposite direction here. Same length, same direction, just going opposite. So changing it, starting to it, stopping. And then I'm going to pick this guy up and I'm going to put him right on the end of this right here. Another way you could do it is we can do it from put it right on the end of this one, and then the resolution vector goes right in the middle. That's another way that we can definitely do that. So I'll show you what that looks like. Resolution vector just means the answer that. Let's see if I can pick this guy up. I don't know if I can or not. There we go. Oh, it's going to go off my screen. Pew. I'll move this guy down. Oh my. Come on, guy. Okay, how about if I redraw it? Even better. All right, so there's D. And there's F, the opposite of F. And if we just go ahead and draw a parallelogram around this, so we'll go ahead and copy this one and we'll put him over here, and copy this guy and put it right here. This is one of the ways I really like to do this. And then my resolution vector will go from here to here, from corner to corner. So that's taking D and subtracting F from it. Resolution vector is here. So it's the diagonal of that parallelogram. So taking the original vector, so this is the opposite of F going in the opposite direction, and this was D, and putting them initial point to initial point, copying those vectors over, and then going from starting point to stopping point. All right, another way to do it, I take D and I put F here, the opposite of F here. Oops. So I go initial point to terminal and then initial to terminal. Now my answer goes from initial to terminal. So very similar way to do it, just without drawing the parallelogram. So my final answer is here. I'll change the color of it so you can see it. There's my final answer in purple. It's the same vector as that one. All right. Well, that's it. That's part 2 of chapter 8 test. This is Coach Lowe, and I'm out.